Just very quickly write down the formulas that we have learned so far. All right, definition for current. Can people just shout out? Current is the rate of flow of charge. EMF, the work done to drive 1 unit charge where? Yes, around the complete circuit or through the complete circuit. PD, potential difference. Thank you. Okay, work done to drive 1 unit charge through the component. And then resistance is the ratio of the potential difference across the component to the current flowing across it. Okay, then R equal rho L over A. All right, we will go through the worksheet later for this one. Okay, then for series circuit. Okay, series circuit, you tell me. The three formulas.
I1 equals I2 equals.
Okay, I equal I1 equal I2. Then V. Yeah, I'm asking him because you answered all the question already. Yeah. V equal IR. V equal IR is already here. The sum of the potential differences is equal to the EMF. Then the resistance, well, I assume that you all know, I cannot assume that. Effective resistance is equal to the sum of the resistances. All right? Hey, you're pure science student? You sure? Okay, then parallel circuit.
What did you mention about potential difference earlier?
Sorry?
What did you mention about potential difference earlier?
I don't understand what you mean.
You talked about potential difference earlier, the E equals to V1
So you're asking me what I said, is it?
Yeah.
I said that the EMF is equal to the sum of the PDs, all right, in a series circuit. Okay? What does PD mean for you? Huh? Some rubbish, man. There must be some rubbish. What does it mean? Huh? Some profanity. Okay, never mind. Tell me later offline. Okay, the recording is still going on. All right, so parallel circuit. Tell me, parallel circuit. The three equation. Don't look at him. His shirt very ugly, so don't look at him.
Oh, are you ready that slide?
I'm just kidding, okay? Just kidding. Yeah, quick. This one, if your Chinese, you didn't bring the 作文纸, you can borrow from him.
So it's on graph paper lah.
Oh, graph paper, yeah, okay, graph paper. All right. Hey, quickly! You don't know? Hey, you guys, cannot, not acceptable. Next lesson I come, I ask you, right, you don't know, you write 10 times. Okay? Yes. Okay?
No way! You're so smart.
Not helpful. Quick, you want to say again? Okay, V is constant. Or you can write V equal V1 equal V2 lah. Okay, then? Good. Okay, thank you. All right. Okay, guys, this one must be committed to memory. It must be like, anytime I ask you, you must know. Okay, you don't need to. It shouldn't be the case where exam come, then I start memorizing. No. Okay. So I want to force you to memorize this. Okay. So this one, this set. Next lesson, I'm going to ask. You don't know. I'm going to ask you to write 10 times. Yes.
So for potential potential difference in the parallel circuit is just
Parallel circuit, PD is constant. No? For parallel circuit, right, if I want to write it in words, then EMF is equal to PD in a parallel circuit. This in a parallel circuit. How to turn off the AI thing? All right. Okay. So for parallel circuit, EMF is equal to the PD. All right. Okay. So let's move on. This is actually all the basics only. These are all the basics. Okay. If you don't even know the basics, how are you going to do the more difficult questions? Now we are going to talk about potential divider. Okay. Potential divider. If you look at page 316, there's one example there. I will use that as an example. Okay, now if you have two resistors, all right, in series, okay, in this case is 5 ohms and 15 ohms, and they are connected in series, right? Okay, to the power source, in this case is 2 volts. Okay, and I want to know what is the potential difference across each of them. All right, we call the first one V1, all right, V1, and we call the second one V2. Okay, there are, of course, you can do it in the traditional way to find the total resistance, and then you find, okay, let me show you. Okay, the traditional way, method 1, this is the traditional way. You find, to find the potential difference V1 and V2, I can find I first, right? Okay, can someone tell me what's the value for I? What's the working to find the current in the circuit?
you find the effective resistance after you take the voltage about effective resistance.
Yes, good. So 2 over 5 plus 15, agree? Agree or not? Vince seems to be digesting his food. Are you with me? So, do you agree with what he said? He said this.
I think not exactly that. You must flip it around for that.
Must flip it around, are you sure?
Effective resistance. Oh, yeah, correct. Yeah.
This is a series circuit. This is a series circuit. Alright, this is a series circuit. So 2 over 20 is 0.10, right? Okay, so therefore V1 is equal to 0.1 times 5 is 0.5 volts. V2 will be 0.1 times 15. Right, you get 1.50, actually 1.5 because 2SF. Right, 2SF. The artificial intelligence is really irritating me. It's trying to help me, but I don't really need its help. And see, now I don't know what is it trying to tell me. Is it maths error? Okay, guys, wait. Now, this is the traditional way of doing this, all right? But there's a faster way because we know that the ratio of the resistance is actually the same as the ratio of the voltages. Okay? All right? So actually, if you know the ratio, you can just straight away calculate. So this is known as the potential divider formula. So what does the potential divider formula say? All right? It says that R1, which is any of the resistance, let's call this R1 and let's call this R2. Okay? R1 over the total resistance R is equal to V1 over the total EMF V. Okay? Now, your textbook writes it as, okay, your textbook makes it more complicated. It says R1 over R1 plus R2 is equal to V1 over V1 plus V2. Okay? Is that how they write it? I actually don't bother because I don't want to make it so complicated, right? They like to make it so complicated. Yeah lah, whatever lah, okay? So, basically, right, the individual resistance divided by total resistance is equal to the individual PD divided by total EMF, all right? Okay, so in this case, let's say I want to find the resistance R1, right? So this is method 2. Okay, so R1 over R equal to V1 over V. So R1 is what we want to find. Total resistance is 5 plus 15, right? 20. Then V1 is, sorry, R1 we know. What am I saying? R1 is 5. Okay, R1 is 5. Oops. I want to use object eraser. So 5 over 20 is equal to V1 over total EMF is 2 volts. All right? So that means 5 over 20 equal to V1 over 2. Okay? So V1 is equal to 5 over 20 times 2 is how much? 10 over 20, 0.5. Okay? 0.5 volts. Then R2 is the same thing. Actually, once you know V1, V2 is equal to, how to find? Once you know V1, you know V2, right? What's V2? Yes, just take the total EMF minus V1, right? So 2 minus 0.5 is 1.5. Don't need the 0.
Does this formula apply for both series and parallel?
No.
So only for series?
Only for potential divider cases. All right. So it's like this. So you can find this much easier if you know the ratio, right? So I can use it for the other side also, but it's very silly to do twice. I just show you that if I use it for the other side, R2 over R equal to V2 over V, right? That means I take 15 over 20 equal to V2 over 2. Okay? So V2 is equal to 30 divided by 20 is 1.5 volts. Okay, so I can do it for both R1 and R2. You understand? Right? I can do it for both R1 and R2. But usually when you do for R1, you don't need to do for R2 already. You can just straight away take EMF minus the PD. Are you all with me now? Any questions? So you all understand the concept of this potential divider? Basically, the ratio of the resistance is the same as the ratio of the PD. So once you know the resistance, you will know the PD already. Okay? All right? Can? So if you look at the ratio, right? Okay, just to point out to you, the ratio of the resistance is 5:15, right? Or in other words, you reduce it to least common multiple is 1:3, right? 1:3. So you notice that here also 0.5 and 1.5 is also 1:3. Also 1:3. Okay, so the ratio is the same. All right? Okay, so this is useful because if you are not able to find, if they don't give you enough information for you to find the current using method 1, you can still use method 2.